Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Well, happy Thursday to you, and I'm not even going to go, I can see the weekend from here. I'm not even going to say it. So, even though I can. And it's the second to the last week of the quarter. Next week's the last week of the quarter. No tests next Friday. So, no big tests next week. Maybe a quiz, maybe Wednesday or Thursday. We shall see. So tomorrow's test is a biggie. I'll get to that in just a little bit. I am still celebrating, as you can see, with my NASA hat, my favorite, I've got my absolute favorite Aloha shirt. I am celebrating with, like you got to do, I am celebrating with an Andes mint. I hope you enjoyed yours. Are they not amazing? QT, that's where you can pick them up. Anyway, SSR. So anyway, worthy of we've got a rover on the surface of Mars celebration. So I think I'll do a backflip a little bit later. Won't be on camera though, because I don't want you to see the ambulance that comes and gets me and hauls me away because I hurt my back. So probably won't do a backflip actually. So I'll get a Pinocchio for that. No backflip, but I'd like to do a backflip to celebrate. Anyway, it is so cool. Don't even think about it. Don't even think about it. I bet I don't need my journal today. Of course you do. So you've got your journal, and you also have, of course, in your homework, in your lesson planner, BFT tomorrow, big fat test. More about that in a little bit. I will show you some things about it, so coming up in just a little bit. Okay? So anyway, big deal. And I do now have up on Wednesday's homework. I posted it today. It's actually Wednesday late afternoon, and I put it up about an hour ago. All the topics and many specific questions in the answers on Wednesday's homework notes on RenWeb. So it's up there now. It's like a study guide. So now, if your parents ask you, well, what is on your test? And you go, I have no idea. So, or if you say, Mr. C never tells us what's going to be on the test ahead of time. You know that absolutely is just the opposite. Every week I tell you, and I post it on RenWeb as well. So, anyway, you will get a major Pinocchio. I wouldn't say that to your parents, or it'll be really embarrassing as you see your nose immediately grow 3 feet longer, 3 foot longer. That'd be embarrassing. Just there it goes, because you know I've told you exactly what's going to be on the test. So it's up to you to triple R it. That's your part. Anyway, I've got a photo up of Mars right now, so you can see that photo of Mars up there, and I think I'll leave it up there in the corner if my son-in-law Aaron can keep it up there, and he's good at that. So anyway, and the view from the Perseverance rover. Very, very cool stuff. So just really, really, really neat. I can't tell you just how cool it is to have seen that, and that kind of thing doesn't happen very often, where you get to actually pay attention and live in my case, well, 7 minutes delayed live in my case, as it came down to the Martian surface and everyone wondering, will it soft land or crash land? So anyway, very cool, super cool. So anyway, look what I have. I actually have the test right here. Here it is, the test. Tomorrow's test already printed. And really quick, is King Henry going to be on it? You bet. And a number of other questions about the metric system. So, is everything about atoms and matter going to be on there? You betcha. Do you have to know the names of some of the subatomic particles? You betcha. So, there they are right there. Do you have to know the 6 elements that we've been talking about? You bet. Carbon, nitrogen, oxygen, iron, hydrogen, and helium. Yep. So they're going to be on there. And then I want to spend time on stars a little bit today, and the Orion, and then on the age of the universe. I want to spend some more time on it, and I do have some questions about the age of the universe, which I'll get to in just a minute. It is estimated, you're going to have a hard time seeing this maybe, but maybe not. Look at the top. It's now estimated that there are perhaps as many as 10 to the 24th stars in the universe. That's a 1 with 8 series of 3 zeros behind it. It's estimated there are 2 trillion galaxies. 2 trillion galaxies. And the nearest galaxy to us, I'm not going to show you a picture of it today, but it's Andromeda, and it's 2.5 million light years away. So it would take light, if tonight you look through your telescope at Andromeda, it would have taken 2.5 million years for light to reach us from Andromeda. That's just the nearest galaxy. Then there are the next galaxy, and there's 2 trillion of them. And they are great distances apart. I'm going to tell you right now what space is like, and it's on the test. 2 adjectives for space. Are you scurrying really quick to write in your journal? You should be. Space is humongous. It's huge. And it's mostly empty. There's mostly nothing in between stars and mostly nothing in between galaxies. So, huge and empty. Nothing there in between the stars to speak of. Vast distances. The nearest star to the Earth at night, the sun during the day, of course, but the nearest star to the Earth at night is Alpha Proxima, and it takes light 4 years to get here from Alpha Proxima, going 200,000 miles a second, the speed of light. 200,000 miles a second. I'm not going to ask you that number. I mentioned it in the test, though. So light travels 1 million miles every 5 seconds. Whoa, it's going fast. Yeah, it's ripping. And yet objects are so far apart. So Alpha Proxima, the nearest star, or Alpha Centauri, a neighbor, those stars are about, so it'd be 6 trillion miles times the 4 years. That's 4 light years. The distance light travels in 1 year, 6 trillion miles. That's a light year. The distance light travels in 1 year is called a light year. A light year. So the light from Alpha Proxima, the nearest star to the Earth at night, 24 trillion miles away. What's in between? Us and them, or them. Us and that star. Nothing. It's empty. Why did God make it so huge? Well, Psalm 19:1, the heavens declare the glory of God, the greatness of God. It's to show His greatness to us. So we'll want to know Him. Boy, it makes me want to know Him. What is He like? He is so awesome. He is so amazing. He's so powerful. He's so all-knowing. I mean, you just can't quit kind of bragging on Him. He's just so amazing. So we just brag on you, God. So I wanted to tell you that sunlight, if you're outside, and sunlight strikes any part of your skin, that sunlight left the sun 8 minutes and 20 seconds ago. 8 light minutes and 20 light seconds ago. It's 93 million miles away. It took 8 minutes and 20 seconds to get here, traveling at 1 million miles every 5 seconds. So what's in between? Not much. Yeah. Once you get past the solar system, which you get past very quickly, nothing there. It's empty. So space is huge and mostly empty. What did God use as the glue to hold the universe together? Besides his power. It says in Colossians, he holds everything together with his power. What force did he use? What scientific force? Isaac Newton studied this. Gravity. Force of gravity. So he used gravity to glue the universe together. The distances are just right. The masses are just right. Their speeds are just right. And their gravity is just right to hold everything together. We think there's a massive black hole at the center of the Milky Way galaxy that holds the Milky Way galaxy together. Anyway, all of that information, and I'll go over a few things in a little bit. You know, you have two 10-pointers on the table that you can show your parents about. Show them Orion and Sirius. Remember the reason Sirius twinkles or sparkles? Because its light passes through the atmosphere that's bouncing around. So the light waves get bounced around on their way to our eyes. And it looks like the star twinkles. So we've gone out 2 nights with the grandkids and looked at Sirius, the rainbow star. And right now you see a picture of the rainbow star. And this guy took pictures of it at different times when it was giving off different wavelengths of light, producing different colors. So isn't that cool, that image you're looking at right now of Sirius and all the different colors that it produces? So brightest star in the night sky for us because it's huge and it's relatively close. Not as close as Alpha Proxima, but Alpha Proxima is not that bright. Sirius is. So anyway, all of that. And then one last thing I want to talk to you about. Many scientists, not all scientists, but lots of scientists, I told you this already, assume that the universe is 13 billion years old, and that the solar system is 4.5 billion years old, including Earth and Mars. But it's just an assumption. It is assumed. Did I mention assumption? Did I mention it's merely assumed? You can't prove the age of the universe scientifically. You cannot prove the age of the Earth. You cannot prove the age of Mars. But it's just assumed that they're super old, billions of years old. Why? Because it fits the slow evolutionary process. Let me show you how they arrive at this. Here's a chunk of sandstone. Can you see some of the layering on it? I don't think the camera's picking it up. But you can see many, many, many layers of sandstone. Now, an evolutionist would look at this and go, at least millions of years old. Why? Or hundreds of thousands of years. Because their assumption is that each layer of sandstone took a long time to form, to get laid down. Takes a long time. So here's what their assumption is. That since one layer took a long time, it must have taken incredible amounts of time for the whole number of layers, or thousands of feet of sandstone, like up in different places where you see lots more sandstone layers. But it's just an assumption. Let me read this to you again. Here it is. The widely accepted age of the universe, I think I read this to you all already, is currently 13 and change billion years old. In the solar system, including the Earth and Mars, 4.5 billion years. Listen to this. However, this is written by a PhD scientist who used a bunch of other PhD scientists. However, no scientific method can prove the age of the Earth and the universe, and that includes the ones that are listed here. There's over 100. And it goes on to say they involve making assumptions about the past. What's the word? Assumptions. Is that on the test? You bet. Assumptions. They're only assuming it's that old. They're assuming it. But they pretend like it's proven. Oh, no, it's not. So every one of their so-called proofs is an assumption. For instance, here's another one. Okay? The Earth is way too hot inside. If it's billions of years old, it should have leaked out all its heat. Do you remember this? The moon is too hot inside. It should have leaked all of its heat out too if it's billions of years, but it hasn't. It's not that old. That's the reason. God most likely created it thousands of years ago. He didn't create it billions of years ago. Here's another one. The comets keep coming back and go around the sun. You know this. They should have all, because they're made of ice as part of their ingredients. As they go around the sun, what happens to the ice layers of a comet? They melt some. So if they've been coming around the sun for billions of years, they should have melted a long time ago. They should have melted. They haven't. They're not that old, comets. That's the reason. They're just not that old. Now, there's a whole bunch of other lists in this. Let me give you some of them. Here's one of them. The data for the first woman, and I'll just read a little bit this to you. It's kind of cool. It's called Mitochondrial Eve, and it says this indicates all women have descended from a single woman called Mitochondrial Eve. This doesn't prove that she was the only woman alive at the time, but is consistent with it. So not that old. She wouldn't be that old, the first woman. And it says this, it directly challenges the evolutionary long age claim. If correct, it means that Mitochondrial Eve, the first woman that we have mitochondrial data on, lived some 6,000 to 6,500 years ago, right in the ballpark for the first woman who lived, the actual Eve. So anyway, more data. You could just mention Mitochondrial Eve. Here's another one. Dinosaur blood cells, blood vessels, blood proteins, and DNA are not consistent with supposedly 65 million year age. It makes more sense if the remains of these dinosaurs are only thousands of years old at the most, because all of that, DNA, blood vessels, blood cells, hemoglobin, all of that would have broken down by now. But it's still there in the tissues, in the fossils, some of the fossils. So it just shouldn't have been there. And then here's one other one. In between sedimentary rock layers, if each layer was laid down over a long period of time, there should have been erosion of each layer. But when you look at individual layers, there's not erosion between them. They're flat surfaces. Do you get that? So that's indication they were all laid down at the same time, these sediment layers of rock. Most likely laid down by what? The GGF, the Great Global Flood. So no erosion between sediment layers like they're supposed to be. Anyway, big deal. So comets should have melted. The Earth's too hot. The moon's too hot. The sedimentary layers don't have erosion on them. So Mitochondrial Eve, not that old. The evidence, the DNA essentially for the first woman. And then dinosaur fossil remains shouldn't have DNA in them or cell parts. if they're billions of years old, in fact, it would have broken down in thousands of years and it's still there. All evidence that the Earth is not that old. So that's the Earth, the solar system, and there are lots of evidences too for the universe itself. So the major word you're looking for, assumption. Assumption. Evolutionists assume it's old because they don't believe in a God, so they believe everything happens slowly over a long period of time. And yet there's a lot of evidence for fast and not that old. So anyway, so I hope you wrote a few of those down. So now I'm going to have my daughter Laura come in, and she is going to give you some fantastically great information on your superpower and how to kind of detail how to develop it. So it's important. Take a note or two. There are a couple of superpower questions on the test. So take it away, Laura. Away you go.
Hi, this is your magnificent brain, Learning with Laura. And I know that the last time we spoke, I really went to kind of part 3 of all the things that make you you, of all the skills, talents, abilities, interests, all those things that make up who you are. So basically your superpower. And today I wanted to talk a little more about it, but I wanted to go in a very specific direction. Last time I touched on the idea of grit, and I wanted to unpack it a little further. But first, I wanted to really give a little bit of a background on grit and why just acknowledging it is important. In many years previously, including when I went through high school, a lot of emphasis was put on intelligence and IQ, and even in talking about Gardner's intelligences, some of what it misses is that we have some control over what we can develop, over what we focus on, over the areas of interest that we explore. Even areas that don't come naturally to us. I may not be very good kinesthetically in sports, but if I work at it, I will become better. And I think that by not acknowledging the grit aspects of this, the amount of time, energy, passion, motivation we put into things, we kind of leave how we see the development of people and the possibility for success in a given area up to one given test or one given these are the intelligences that are mine, rather than acknowledging that no, we are people who can develop and can transform in a lot of different areas if we choose to work at something, if we really dedicate the time, effort, energy into it. We can grow in areas that aren't our strong suits. For instance, I wasn't always good at math. I had a lot of issues with numbers, reversing them. I have a learning disability that really sometimes I have difficulties with numbers, so I would do a lot of checking. I would be hypersensitive to what it is I was working on and just making sure that the numbers were there and that I was saying them correctly, because I would invert them often, or reverse them, I should say, often. I worked hard at it. I didn't come naturally. I had to do a lot of extra outside the classroom type learning things. I had to seek out a bunch of other resources. It wasn't something I naturally enjoyed. It wasn't something I naturally was good at. But in the end, it was actually a good portion of my actual career as a research administrator. I managed accounts. I managed numbers. I actually created Excel documents that became living active budgets that people would use. I used an area that wasn't my strong suit. I developed it over time, even tracking down people who spoke about it in a way that made sense logically to my brain, and was able to make it a strength. I'm not saying that's something that you want to do long term with areas that you don't consider strengths, but what I'm saying is don't let those areas hold you back. Remember that you have some control over what it is you decide to do, put time and effort into, and that you can choose to work on something, develop it. Not that it's what you necessarily need to be doing. Sometimes we just need to identify something and say, okay, this isn't something that I really get a lot out of, or I really enjoy or feel passionate about, but it's something that I can put the time in to pass this class, or I can put the time in to do this one aspect of this project, and then I can kind of put it behind me. It's good to know that you have those choices of where to invest time, both short-term and long-term. So, grit. Last time we talked, I talked about it as perseverance and passion that help you level up, to continue to dedicate time today, tomorrow, and the next day to continue to grow in a given area. But there's also a lot of other research studies that are going on that have identified additional things just to be aware of that really does make up, at least they believe make up, what is grit, what keeps someone continuing to work on something even when it gets hard. So in addition to perseverance and passion, they talk about courage. So basically when something isn't comfortable, when something makes you a bit afraid to go out and do something, courage to face that and continue on. I think sometimes we don't realize that the things that we need to do to develop actually could be potentially scary or intimidating. And sometimes it's just taking that step out to try and just see what happens. And not being afraid of failure or making a mistake. Because I would actually say when we fail at something, when we make a mistake at something, we learn about what it is, what areas we need to continue to develop. When we can look back on our performance and say, well, I didn't do as well in that area, but I did really well in this one, we can see the areas that we've developed really well. We can see that as a win, and then shift our focus onto the things that need our attention in order to continue to level up in that given area. So that we're not just focusing on the things that are our continued strengths, but we're shifting to where are the places that we need that additional energy, that additional focus to really develop in those areas that are still not our strong suits. Also, conscientiousness. So when we're coming to something, when we're working on something, paying attention, seeing what it is that's working, seeing the things that aren't, being focused on the details, not just doing something, but actually being thoughtful about what it is you're doing, being analytical about what worked, going back in and then choosing the things that really might need that additional effort, conscientiously choosing to work on that over and over and over again. Perseverance we already talked about last time. It's that doggedness, that stick-to-itiveness, that even when it gets tough, continuing to work on it over and over and over again. And then resilience. Resilience is almost that ability to weather disappointments, being able to weather setbacks and continuing to show up over time, not allowing those sometimes negative messages to kind of permeate yourself, but really reminding yourself why it is you're working on it and focusing forward so that when those setbacks happen, you don't allow it to be an excuse for you to just give up, throw in the towel. You see it as, okay, this is a setback, it's a challenge, and I'm going to rise to that challenge and overcome. We all will face obstacles in whatever it is we're learning. And when you find that resilience to stick with it, to kind of keep going, even when it feels like it's not very hopeful, that is so important in overcoming those obstacles whenever they show up. And then passion. And really, what passion is being excited about something, being enthusiastic about it, being interested. Even if it's not an area that you naturally are excited about, find the thing that you can personally get excited about, get motivated about, internally, not just external things. Many external motivators we have no control over. So if our goal is to win first prize in, say, a race, if our goal is to beat out our entire class on this test, there is an element to that we cannot control, and that is everyone else that we're working with, everyone else who's running that race, everyone else is taking that test. However, if you can say, my goal is to be better than I was last time, you have total control of that. You can say, okay, I'm working to beat my time in, say, the 100 meters from what it was a week ago. Or say that on a specific test you got a certain grade and you're saying, okay, my goal is to study a bit more and try to get a higher test. Yes, there's a test grade. Yes, there's some things that you can't really control over that. You can't control how difficult the test is, but what you can control is you in that situation. So, for now, I'm going to leave it there in talking about grit. I will be back in probably another 2 weeks to talk about how we view our minds, whether we view them as fixed or as growing and dynamic, and how changing the script of what we even tell ourselves can really help us continue to keep our motivation and to move forward. But for now, I hope this has been helpful. I hope you have a wonderful day, and I'll talk to you in a couple weeks. Bye for now.